My name is Brandon Dennis Chow, matrix number 8B190103, and I will be presenting for lab experiment 2, activity 1. So for the first activity, here we see the circuit, and then we have 12 volt DC battery, switch S1, S2, SG, thyristor, lamp, and R1 as the resistor, 4.7 kilo ohm. So for the first one is S1 and SG is both off. So for S1 and SG both off, we see the lamp is off. And for S1 on and SG off, the lamp is also off. And for both S1 and SG on, the lamp is turned on. Then after that, we off SG, but the lamp is still turned on. And after that is both off, and here we see the lamp is off. So for the second part, the second part is for switch S1, SG, and S2 all off, then the lamp is off. For S1 on, then the lamp is still off. For S1, SG on, the lamp will be turned on. And then for S1 on, SG off, S2 on, this one SG off, S2 on, the lamp is still turned on, but if we off S2, then the lamp will be turned off.
Good day to doctor. My name is Gan Yii Fan, AE190077. Today I'm going to do a presentation on exercise 2, activity 2 regarding silicon control rectifier SDR power switch. So I'm going to use a multi-sim simulation to do the activity 2 characteristic. And based on the figure 4.2 SDR power input, so we have this seven component list. So I'm going to do it in the simulation. Okay, first we need a power source. We're gonna have a switch and a resistor. Take switch, this P1. There are two switch in the circuit. And I'm gonna have a resistor of a 4.7 k ohm. Resistor here. And then I'm going to have a rubber resistor of a 10 k ohm. Okay, so I'm gonna have a multimeter over here, and then over here. Okay, so basically we just connect all over the wire, and we're gonna have this. Okay, so I'm going to connect the circuit as in figure 4.2. Then we're going to close S1 and set the VR1 to its minimum value, and then record the anode current and the voltage across transistor. And input here, close S1, we're gonna have here. Okay, our minimum value is 0%. So we're going to have a jot down our value over here. Okay. So after voltage setting, it's going to be 1.567 microampere. Okay, it's going to set it after for a while, and okay, so 1 point something already. After that, we're going to close S2. Then we're going to see the value. Then we're going to determine the holding current. Okay, close S2. You can see the bulb over here is lighted up. So whenever I take 5%, so it's not light up. So the holding current is 21.733 milliampere. Okay. So, okay, that's it. This is my simulation. Thank you.
Hi, Assalamualaikum. My name is Ellie Ardilla Binti Nasarudin. My matrix number AE190074. And then I will continue for activity number 3, which is phase control. Okay, so this is the circuit, which is figure 4.3, SER power switch with AC input. Okay, so SER stands for silicon control rectifier. Okay, so at the circuit, we have AC supply, we have resistor and variable resistor, and then we have capacitor, we have SCR, we have a diode, and also one load, which is lamp. And then also we have oscilloscope for see the waveform of VL, and will be one oscilloscope here to see waveform of VS. Okay. So from the table, we need to measure the value of V out and I out DC of 3 delay angle, which is alpha 1, alpha 2, and alpha 3. Okay, so before that, we need to state the value of alpha 1, alpha 2, and alpha 3. Okay, so for alpha 1, which is minimum, we use 0%, and then for alpha 2, which is mid value, we use 45%, and then for the last one is alpha 3 is maximum, which is 100%. Okay, so move to the circuit simulation. We have AC supply with 12 volt with peak, and then frequency of 50 hertz, and then the resistor with 470 ohm, and then a variable resistor with 10 kilo ohm. Okay, and then we have capacitor with 330 nanofarad, and then this is the SCR, which is we use 1BH62, and then the diode we use 2N1599, and then we have a lamp, which is a load, and then we have two multimeter, which is this multimeter for measure the I out, and it is the multimeter for V out. And then we have two oscilloscope here. This is for VS and this is for VL. Okay, so we start with 0% of delay angle. Okay, so we got value of V out is 3.362 volt, and then for I out we got 233.52 milliampere. And then we also see the waveform. So this is the waveform. Okay. Okay, so next we try for 45%. Okay, so for the 45%, we got V out is 2.47 volt, and I out is 171.5 milliampere. And the oscilloscope, this is the waveform. Okay. Okay, so next, the last one is for 100%, which is for maximum angle. So we got, actually for maximum value, we got negative values. Okay, so I think, yeah, for oscilloscope, so this is the oscilloscope. So that's all. Thank you.